to the second video in the two-part series, where today I will be explaining to you how the mechatronics and circuitry are seen before you right here helps us make the rocketry alarm system, which I've been building for task 3 of Year 9 STEM. Now, as you can see, there was a USB-C cable connected to this Arduino. Now, normally, this USB-C would be connected to a computer via an adapter, which would be providing the Arduino with code and power. The Arduino would process the code and send it to the rest of the circuitry, rest of the electrical components, as either an input or an output. And it will also be providing them with power, as well as this external 9-volt battery, which we really only need because there are quite a few electrical components, and without it, at least one of these electrical components would fail to work due to a lack of power. Now that I've gone over how code and power is supplied to the circuit, we're going to go over these two push buttons. Now you can see this push button is the push button that we use to reset the countdown on the LCD screen, and this push button is the one that actually starts the countdown. I'll just show how that works now. So as you can see, the countdown begins, and now we press this push button and we've gone back to the start. Now this works because, as you can see, we have the reset pin here, which is connected to the push button via a jumper wire. It's connected, we can see reset is connected to terminal 1B of the push button, and then ground is connected to the push button via terminal 2B, which closes this circuit. This bit of the circuit allows the LCD, the countdown of the LCD to be reset. Now, as we can see, we have terminal 1B, terminal 2B, and terminal 1A of the push button, which are all connected to 5 volts. The 5-volt pin is connected to terminal 2B. The ground pin is connected to terminal 1B via this resistor, which stops the push button from frying. And we can see that this terminal 1A, the push button, is connected to pin 7 of the Arduino. Now, along with some code that I explained in the first video that I made yesterday, which you should really go watch, we can see that pin 7 has been turned into an input, meaning whenever this push button is pressed, pin 7 on the Arduino reads if the push button is being pressed, and if the pin 7 detects that it's been pressed, all of this code is started, and that's assisted by line 14, line 15, and line 10 of the code. But there's no really need to get into that. I already explained it in the last video, which again you should go watch. Now that I've gone over how these two push buttons work and how all the code and power gets to the circuit, we're going to go over the piezo and the LED in the circuit, and how they act as a bit more, how they help the circuit really function as an alarm. Now, as you can see, we have this LED here and we have this piezo here. The piezo is hooked up to pin 8 of the Arduino, and along with some code, which you can see here, line 52, we have tone, open bracket 8, comma 466, comma 20,000. This allows the piezo to receive outputs from pin 8 on the Arduino that makes it produce an A sharp note for 20 seconds to show that the countdown has finished. So basically, that piece of code allows the piezo here to start making a buzzing noise. Now we can see the LED here, which is connected to a resistor. But besides that resistor, which stops these two electrical components from frying, we also see that the anode of the LED is connected to pin 6 on the Arduino. And as you can see in line 53 of the code, digital write 6 high, this turns the LED on once the blast off A plus string is displayed. And yeah. Then we can see we have this resistor, which I mentioned previously, and this connects the positive sides of both of the electrical components up to ground so that the circuit is able to close and that the electricity is able to flow so that these two electrical components to work. Now, we've gone over the two push buttons and how they function, the piezo, the LED, the external power source, the Arduino, and what this USB-C cable is doing. Now we're going to go over why we have these hookup wires, the pins on the LCD, what they actually do, and what the LCD does. Now, the LCD is what we call a liquid crystal display. And this basically just displays strings such as blast off A plus, and any displays the countdown. But more importantly than that, we're going to look into what these pins do on the Arduino that allow this LCD to display the countdown. As you can see, we have this resistor here, this 220 ohm resistor that stops the LCD from frying, and this jumper wire. Now, this jumper wire is connected to ground, which is then connected to the anode LED positive on the, it's connected to the LED positive pin, and in combination with the 5-volt pin on the Arduino, which is connected to this resistor here, which connects the 5-volt pin to the LED minus pin. These two pins provide, these two pins on the Arduino provide these two pins on the LCD with power for the LCD's backlight. Basically, what this does is it allows the LCD to be lit up. Without these two pins, there would be no light around the LCD to give, you see this blue light on the LCD. There'd be the LCD would be completely black without these two lights because there'd be no power to power the LCD's backlight. Next, you can see that we have the DB7, DB6, DB5, and DB4 pins. Now, these all provide the LCD with power, and the reason why they are connected, DB7 is connected to pin 2, DB6 is connected to pin 3, DB5 is connected to pin 4, and DB4 is connected to pin 5, is because when searching for open source code to actually when searching for code on the web, I just noticed that this was the most common configuration for this particular solution. So as you can see, we have all of these pins in the code, which are basically set so that they're rigged up. So D7 equals 2. That means that DB7, this pin here, will has to be connected to pin 2. Basically, when I was finding code on the Arduino website, this is what I was given, and so I connected these pins on the LCD up to these pins on the Arduino, because it's just the most common solution that gave me the most options to work with. Next, we have the enable pin, the read and write pin, and the register select pin. Now, these pins are arguably the most important pins on the Arduino, mainly because the enable pin actually allows the LCD to do its job, to actually display strings on its screen. And then the register select and read and write pins allow the LCD to process data, such as these strings. So, as you can see, these three pins all work in combination to help display data onto the LCD. And as a result, they are arguably the most important pins because it allows the LCD to carry out its main function. Next, you can see we have this pin called VO or contrast. And the reason that it's hooked up, the reason that it's hooked up to a potentiometer is because, as you can see, it allows us to, the whole purpose of contrast is to change the lighting on the LCD. Basically to change how powerful the backlight is. As you can see, when I push the dial backwards, the lighting on the LCD begins to dull, and when I push it all the way up, it becomes very bright. This is why it's connected to 5 volts and ground, because it needs to be able to regulate the power coming into the LCD to basically dim the backlight. Next, we have the final 2 pins on the LCD, ground and VCC. Ground, of course, is connected to the ground pin on the Arduino, which allows the circuit to close. And VCC is connected to the power pin on the Arduino, which provides the LCD with power. Now, as you can see, we've about gone over all of the electrical components in this circuit. There might be a bit more that I have to clarify if I haven't already. Basically, all these 3 resistors stop the electrical components on the circuit from frying, if I haven't already stated that. And basically, all these jumper wires just help to connect pins on the Arduino up to the LCD. But besides that, I think I've clarified exactly, been able to explain and clarify exactly how this circuit works to make a Circuitry alarm system with some help from the code, which you can see here, which I explained in my first video. But now that I've explained how all this works, I hope I have done it well and that I will be able to get a 5 out of 5 for this section. Goodbye.